Welcome back, my dear guys. In this video we are going to learn what is resultant of force. We all might have came across this word resultant of forces in the first unit or in our coming units, but we all have to understand the word what is resultant first of all. Then only we are able to solve the problems which are related to the resultant. Fine. Okay, let us take an example. So for it we have to draw a square box which is an object. So this object which I have taken in the space in the sense the body is having no supports at all. If I exert a force on the body starts moving. If I didn't, the body stays as usual. So here what I have done is I have started giving some force on the body in the right direction. So what happens is the moment when I have given a force of 5 newtons on the body in the direction, in the horizontal direction, the body also starts moving in horizontal direction. Till I stop the object, it will not stop and it continues to move in the right direction. Right? So this is the first case. And for the same body, for the same object, if I give a force in the upward direction, the body starts moving in the upward direction until I started stopping the object. The body continues to move in the upward direction. Right? 5 newtons or 6 newtons. And this is nothing but it is going in upward direction because I have given the force in upward direction. The direction of the force is pointing vertically upwards. That is nothing but at 90 degrees. The previously we have applied a force at 0 degrees or 360 degrees. Right? So here in this case the force is directing upwards so that the body also starts moving in the upward direction. If for the same body, for the same object, if I give both the forces, one force which is pointing right side and one force which is pointing upwards, both the forces at the same time, what happens to the body? Will the body move upwards neglecting this 5 newtons which is pointing right side? No, it can't. And will the body move right side neglecting this force which is pointing upwards? No, it also can't. So the body has to do one thing. It has to satisfy both the forces. So that let us write these two forces at a single point within the body. Within the body, let us take. So this force, so for this force, I am pointing it here. This is the force which is exerting 6 newtons. This is nothing but this is by law of transmissibility. I have placed this force somewhere here. Okay, again the force. This force I am placing it here. So when both the forces are acting on the body at the same time, the body starts moving in this direction. The body starts moving. I will change the color. The body starts moving in this direction, somewhat in this direction, irrespective of the angle or the direction. The body starts moving in this direction because the body has to satisfy the force in the right. The body also have to satisfy the force which is pointing upwards. So here what is that body is doing is the body is satisfying both the cases. The body is moving right side, at the same time it is also traveling in the upward direction. So if we represent both the directions in the same single line, this will be the direction and magnitude of the forces. So the final resultant, with what force the body is moving in this direction, it is nothing but the resultant. With what force the body started moving in this direction, with the help of these two forces, it is nothing but the final resultant. Right? Hope you understood. Right, let us erase this all. So here we have taken 6 newtons and 5 newtons, right? Let us solve it and let us find out the final resultant. So here the force which is pointing right side, it is with 5 newtons. The force which is pointing upwards, it is with 6 newtons, right? Here I have to find out the resultant of these two forces. When these two forces are acting on a same body at the same time, the body will attain a new resultant. The body will attain a new force, that is nothing but resultant, and it will be directing somewhat like this. So let us find out what is the force of the object having here when it is moving in this direction, right? So in order to find it out, so let us take parallelogram law of vectors, parallelogram law of forces. Here we have already found out the resultant of parallelogram law of forces, right? R equals to f1 square plus f2 square plus 2 f1 f2 cos theta, where theta is the angle between two forces. And here, what is the angle between two forces? This is first force and this is second force. What is the angle between two forces? That is completely 90 degrees. So here at the place of theta we have to write 90. So let us do it. It is 90. So what is the value of cos 90? It is 0. So the whole term becomes 0. Since cos 90 is 0, the whole term becomes 0. And the resultant comes out to be R equals to, wait a second, R equals to f1 square plus f2 square. That's it. And f1 square and f2 square comes out to be, f1 square and f2 square comes out to be R equals to 6 square plus 5 square, and R equals to root over 6 square, it is 36, and 5 square, it is 25. And what is the unit of resultant? It is newtons. So resultant is also one of the force, since it is combining both the forces, both the initial forces 6 newtons and 5 newtons with the different directions. R will have another direction, at the same time it will have another resultant, right? Clear. So R equals to root over 36 plus 25. How much it is? 61. Root over 61. This is nothing but the final. Let us erase this all. We can calculate root 61 in our calculators, right? And it is nothing but root over 61 newtons. It is the final force which with the body moves with the help of when both the forces are acted on the body at the same time. This is nothing but the resultant. Hope you understand the video. Thank you so much.